Good afternoon, everybody. Welcome to this fourth webinar, jointly organized by EUBIC Coventry University and EBN. I am Laura Lecci, the CEO of EBN, and today I'm very pleased to host this webinar with Paul Ferber, Innovation Director at EUBIC Coventry University. So just the first message for you to know that this webinar is recorded. So if for any reason you would like to stay anonymous, feel free to maybe turn off your camera and don't put any details in your name. Although I invite you very much to be as interactive as possible. Use the knowledge of the speaker, so feel very much free to use the chat either to drop a question, to drop a comment, or if you also have initiatives that can be relevant and interesting that you would like to share today. So maybe just a couple of words about EBN and EUBIC Coventry University. So as far as EBN is concerned, is a pan-European community of business support organization, such as incubators, accelerator, university-led initiatives that support innovative project ideas to transform into reality of successful and scalable businesses. EBN's members are spread in more than 35 countries, and altogether, only last year we supported more than 35,000 innovative companies, which include startups, SMEs, and larger size companies. EBN has been operating for almost 40 years. Next year, we're going to celebrate this big milestone. And probably what makes us a little bit unique, if you like, is that we manage and grant the EUBIC label. Is an official certificate that ensure the quality of the services that all the business organizations that I mentioned just before do deliver to innovative entrepreneurs and companies. Our members stay true to 4 mission commitments, the main 4 mission commitments, which are the regional economic sustainable development. We look very much to make an impact in the region where members are located, the quality of the business support that they deliver to companies and entrepreneurs, the ability to have a steady pipeline of innovative companies that is able to attract funds and funding opportunity, but on the other side as well, the ability to provide these companies with a reliable network of investors, business angel, VCs, and early stage investors. Last but not least, by being a network, we do believe in the power of international collaboration, so we try to foster them among our members and among the companies that our members support. What EBN does, together with the management and the accreditation via the EUBIC label, is also we do provide training and knowledge centers, such as these type of activities, the webinars or publication on specific industry sector. We do foster meeting, a connection, and exchange in order to get inspired and replicate best practice that's come from all over Europe and beyond, as we are lucky enough to count on few members outside Europe. We do facilitate access to EU-funded opportunity, but also other international donors in order for our members to position as experts in innovation and entrepreneurship, as well as in technical assistance type of activities for less developed either organization or innovation ecosystem. And we sort of play as a gateway for strategic partnership with corporate institution, investors, anything that can help our members to better support their companies. but probably there isn't any best way really than hearing from one of our best ambassadors of the community to understand a little bit better who our members are. Paul, over to you.
Thank you, Laura. Great introduction, and good afternoon, everybody, and welcome to this, the final part of our series of joint webinars with EBN. As Laura said, my name is Paul. I'm Director of Innovation at Coventry University and board member at EBN. We have a long-standing relationship with EBN, over 20 years, and our Brussels office colleagues are with us today, but we're co-located with EBN, so it makes absolute sense for us to be hosting this session with one of our key partners. Our focus today is on advanced manufacturing, covering the adoption and application of digital twins and the metaverse. So in a minute, you'll hear some fantastic stories from my colleagues Marcus, together with Nick from Hyperbat. But before that, and I won't speak for very long at all, but I wanted to give you a quick overview of Coventry University as a group, give you a flavour of who we are, what we're about, why we're involved today, some of which, of course, you will hear about in the later presentation. But essentially, we were created as a college of design in 1843, became a polytechnic in 1970, and became Coventry University in 1992. So we currently provide education to around 50,000 students right across the globe. And we have 4 key themes within our 2030 group strategy. First and most obvious is education and student experience. So we look to deliver education that meets the needs of our students and their employers. That's a key thing for us. Research and impact is the second key theme of our group, and delivering multidisciplinary, challenge-led research, which Marcus will talk about today, or some elements that address real-world issues, often linked with business. Thirdly, as partly evidenced by the audience that we have today, we're a global university. We operate at scale with hubs in Brussels, as I've mentioned, also in Dubai, in Singapore, and then most recently Rwanda. And then the fourth and final theme of our overall strategy is enterprise and innovation, which is where my team sits. We work with business and the community, supporting innovation, entrepreneurship, startups, scale-ups, and economic development. So hopefully that gives you a really quick sense of who you are. I'm sure you'll find this session enjoyable, enriching, and exciting. So I'm going to hand over now to Marcus so we can get started. Before I do, well reminded, Laura, an opportunity just to do a little bit of promotion. So in October this year, 18th to the 20th, we'll be hosting EBN Tech Camp with a focus on immersive technology. We'll be launching that next month at the Congress. So you should hear in due course about that event, but very welcome to come and join us here in Coventry, 18th to the 20th of October. So I'll stop there, Marcus, and I'll hand over to you.
Thanks, Paul. Good afternoon, everyone. I will just get my screen shared with you. So thank you for your time. As Paul introduced us, we'll talk a little bit about ourselves. So I'm Marcus Kaufman. I look after a research center at Coventry University, which is one of 15. The research center that I look after is focused on manufacturing materials. And as part of our research center, we have a translational institute here, which is called the Institute for Advanced Manufacturing and Engineering. And in this site, we are focused on working with industrial partners like Hyperbat, and Nick will introduce himself and Hyperbat in a minute. And we do a lot of translational projects where we take the theory from our research groups and we look for opportunities to apply them with our partners to achieve that impact across economic, social, and environmental areas. So one of the most exciting areas of research that we have that we're going to be talking about today is digital manufacturing, and in particular, industrial metaverse and digital twins. And nothing more fits for the introductions than to introduce our physical beings there on our photos, but also our avatars used in the metaverse here. As you can see, they are a little bit slimmer than we are in the real world. They look a little bit younger, but that's one of the perks of being able to create a digital model to represent you in another environment. So that's me, and I'll hand over to Nick to introduce himself now.
Yeah, brilliant. So I'm Nick Hugel, as it says there. I actually did study at Coventry University, so I've been kind of Coventry through and through. And now I work as a lead systems engineer. at Hyperbat, which is on site with the AME, and we produce electrical vehicle battery packs. So we're currently working on a project with Lotus, which I'll talk about in a bit, but that's me.
Thank you. Okay, so the webinar today will really focus into three key areas. So the first area is exploring, this fascinating area of digital twins, virtual and mixed realities, but also application of that in the context of metaverse. And I will explain in a minute what we mean by metaverse here and how that might be different from your assumption of what a metaverse is. We'll then talk about some of the work that we've done here in Coventry University to try to develop and introduce a standardized digital twin adoption pathway. So the link between digital twins and metaverse is really important in the industrial context. The digital twins are the models that represent the physical products and factories that we have, and we can use them in a shared universe, if you like, in the form of the metaverse. And to try to illustrate that more in a practical sense, Nick will be presenting how Hyperbat, which is next door to us here in Coventry, have deployed and used digital twins to develop a business proposition that is quite unique and has a very strong competitive advantage derived from the use of digital technologies. So just as a kind of, outline of the presentation, so we'll cover a little bit of an introduction to industrial metaverse. We'll then introduce digital twins, talk a little bit about the impact and why we think it's so exciting to be doing work in this area. And then Nick will present a use case where he demonstrates the application, and we'll have some conclusions and time for questions and answers at the end of the session. So we will start with the basics. So metaverse, for those who don't know, and I'm assuming some of you might have heard of it before, it is a reference to this notion of a beyond universe, a universe created in a kind of environment where you can create entire worlds, you can create entire systems, and you can interact with that. Now, that's a very vague definition. We like to use a more kind of specific definition of a metaverse, and we use this notion of an immersive and constant virtual 3D world where people can interact with each other through an avatar or a digital twin, and they can do that interaction to achieve a number of different things. The most common view of a metaverse is a metaverse for entertainment. So you play in a game, or you using for some social purposes, or you attending a concert in the metaverse. But also metaverse can be used to make purchases and commercial activity, and the part that we really interest around work and metaverse for the purposes of engineering and manufacturing. Okay, so to try to give you a little bit of a flavor of what the industrial metaverse is and how it's different from the traditional metaverse, I have a definition here that is used by Microsoft and how they split their metaverse working groups within them. So they start with the concept of a consumer metaverse. So this is around enhancing social and entertainment and well-being experiences. So this will be, if you are like me and you have young kids, this will be your kids playing video games online. That's the kind of consumer metaverse. You can, play Fortnite, and you can buy and have access to goods and services through that platform. So the second metaverse in that context is the commercial metaverse. So this is where you have the next generation of immersive relationships with your customers. So you could go into the metaverse to experience, your new car and how you design the interior, how you pick the colors, and how you see that new car. You could design your kitchen. You could, make products and services bespoke to you. But the key emphasis on the second one is not entertainment and enjoyment, is more commercial purposes. You're trying to buy yourself something. And then obviously the final part, and the most exciting in my view and most important, is the industrial metaverse. So here what we are talking about is the use of this immersive world as an enabler to allow humans and AI to work together, to design, to make, to commercialize, to monitor, to maintain technologies in the physical world in a more interactive way. So hopefully that gives you flavor of the distinction. So when people generically say metaverse, and probably you've seen in the press over the last month and a half, that some of the metaverse initiatives are being scaled down, in companies like Meta, Facebook, if you like, and in some large companies. That's mainly the consumer and commercial metaverse. What we see is the industrial metaverse is pretty much booming and increasing exponentially in investment. Now, we like to talk about the key features of metaverse, because it sounds very abstract and it sounds very, from another world, if you like, as it should be with some of these disruptive technologies. But we have some key features, and this is from the European Council report on the metaverse. And we always like to refer to this when trying to get our understanding of what a metaverse is and how it works. So there are 5 key features there that are standard across all forms of metaverse. So the first one is persistent, immersive, and massive. So this is, you have a whole world that you can create, a whole universe, and you can have multiple universes, and it can be as complicated as you need or as simple as you need, depending on your use case. So that's the first key feature. The second key feature is around synchronicity. So it has to be linked to some sort of living experience. And that links really well with the third feature, which is link between digital and real. So you have to have some connection between the physical world and that digital world, and you need to synchronize the aspects of commerce or experience or industrial activity that you are doing there. Now, the first 3 features enable the feature 4 and 5, which is economy. So it can be used in the commerce, it can be used to drive economic growth, economic activity in general, and it also can be interoperable, meaning multiple people from multiple areas, multiple access points and technologies can interact with that at the same time. So the point I'm trying to make here to all of you is, when you hear metaverse, don't just think about Facebook and Meta. Think about this whole other world around industrial application. And I have a quote in there, which I will not read for the sake of time, but it's from the CEO of NVIDIA. NVIDIA has been one of the companies that develop very substantial solutions around the industrial metaverse. And what they are saying there is, industrial metaverse is where the growth is and where the big potential is for innovation and further collaboration across industries, and where we think will make the biggest advances around our global challenges, from sustainability all the way to, increasing our efficiency and effectiveness as, knowledge workers, if you like. So we talked a lot about introducing metaverse, the different types of metaverse, and then key features. What I want to end this introduction to metaverse with is the big potential. And this is just 4 bullet points that we selected based on our view of digital manufacturing and digital engineering, and how the metaverse has a massive potential to increase our collaborative potential, allowing people to come together virtually in virtual and augmented spaces. So this is beyond a Teams call or a Zoom call. This is a meaningful interaction in an environment that reflects your production line or reflects your product. And we can all get around that product as we would in the real world, and we can make adjustments, we can make decisions, we can instigate investigations and development of products and processes. So that will no doubt enable better decision making because of that power of collaboration. And that decision making will change how products and services are made and delivered to our customers. And in turn, that will change how customers interact with businesses, universities, service providers, and so on. So it's really around transforming the way we design, make, and sell and service our customers. And that's where we think the big potential is. Now, underpinning the metaverse, and in particular the industrial metaverse, is the concept of digital twins. So to make the metaverse environment meaningful beyond just a game, you need that connectivity and that link with the real world. And that's where the digital twin comes in. So there is, 2 forms of digital twins that we normally refer to. The first one is the avatars, and you can see my and Nick's avatars at the top in there, but at the bottom, what you see is more aligned with the digital twins that we will be working with in manufacturing engineering. So you see the real factory, the right-hand side, and then you see the simulated factory in the left-hand side, and those are directly connected. There is an exchange of information between them. So when you immerse yourself into that representation of the physical world, what you see in there is meaningful, is reflective of real world. Okay, so that's where the digital twin features into the metaverse. And I honestly believe the digital twin is the most important aspect of a metaverse. And for that reason, we prepared a few slides to introduce you to the concept of a digital twin. Now, we work a lot with industry here in the UK and across Europe. And what we find is that there are many definitions of digital twins, in the same way as there are many definitions of metaverse. And we like to start the discussion on digital twins by making it very explicit. What do we mean by a digital twin? So in our case here, we refer to a digital twin as a digital representation of a physical asset that is synchronized at the appropriate level of fidelity to deliver value. So it might be very complex, it might be very simple, but whatever level of complexity you need, it has to be aligned to your business case that you have for the application of digital twins. So it starts with a digital representation. So this is a data set, a model that virtually represents your physical thing. That representation can be at different levels of fidelity. So in certain cases will be a CAD model. In certain cases will be a full multi-physics model that represent a product or a process or a person, if you like. It will all depend on the use case. It will be synchronized at different levels. So in some of the factories, we have synchronization at 30 hertz, 50 hertz, 300 hertz. In some other cases, we have synchronization a minute or even 15 minutes synchronization between physical and digital model. What dictates the degree of representation, fidelity, and synchronization, as I say, is the value that you're trying to achieve. So it's important to use here a reference model, and we do work a lot with the Industrial Digital Twin Association, which is a European group. It was born out of the Industry 4.0 platform in Germany, and they created a standardized model called asset administration shells, which basically allow you to standardize how you create digital representation of physical assets. So what you see at the bottom left there in gray, that's your representation of the physical asset. Imagine that is a motor that you are making, and the blue shell around it is where you have all the data about representing that physical asset in the digital world. So that can be made with as many submodels that represent as many parameters or characteristics of that physical asset as you wish. And it's very important to make sure, if you want it to be interoperable and if you want to share that in multiple environments, that you adhere to standards. And that's why we work a lot in collaboration to innovate and create digital twins to make sure everybody is creating those in alignment with the relevant standards. So hopefully that's a kind of overview of the definition of digital twins. Now, there is a few standards that we use. Some of those are very detailed, some of them are very high level, but all of them agree in a set of key steps or features that you might need in your digital twin. And this is an extract from ISO 23247, which is automation systems and integration, and it looks at a digital twin framework. And they talk about, a digital twin being made of or consisting of a digital twin data set. So this is the raw data that you use to represent the thing. A digital twin model, which is how you configure that data into something intelligible. And then you have a services interface, which is where do you grant access to that model in terms of functionality to potential users. So an engineer designing a product might not need full access to the whole data set. They might need access to a few parameters there that they want to simulate or they want to predict in a particular environment. So it's important to understand the complexity of going from data sets to digital models and then to digital interfaces. And we'll talk a little bit more about those when we get to our digital twin adoption pathway in a second. But just to reiterate the potential of digital twins, I think, you know, this ability to represent physical things in a digital world with high degree of fidelity and confidence unlocks a potential to, you know, to have closed loop design systems, closed loop manufacturing systems, where you can predict what is going to fail and address it before it actually fails. So your productivity and quality levels are much higher. So the global market for digital twin technology was 10.3 billion in 2021, which is a little bit out of date. I couldn't find anything more recent. But in 2022, there was a forecast that the market will reach 55 billion in the next 5 years. So by 2027, 2028, that will increase fivefold. So massive potential there for growth. And clearly, you know, we're trying to work with partners to enable that growth and to benefit from that market. And the way we do that is through, you know, really, you know, trying to have a showcase of different use cases. And what you see there is a very busy slide, but it's just a series of use cases that we already implemented in terms of digital twins and industrial metaverse across multiple phases of product and process life cycle, going from as designed to as built to as used and maintained. And each of those will have a series of individual requirements for how you model a product or a process and how you construct some infrastructure. So it's really important that for, you know, a small company or a medium or even a large company looking into industrial metaverse and digital twins, you will start from your own business model. What is it that I'm trying to achieve, and how can I identify a use case that has been proven and tested that can contribute to me achieving that goal? Which brings us to the key challenges with digital twin adoption. So one that is very common, and you probably have encountered it already, is the lack of a common definition. So we can see, you know, anything from people referring to a CAD model or a digital model that is not connected to anything physical as a digital twin, all the way to a fully fledged, you know, airspace engine, fully connected digital model that you can see in real time, where the aircraft is flying and how many, you know, hours you can run that engine before you have to maintain it again on the ground. So there is a little bit of confusion, which doesn't help in terms of building upon existing models and standardized models. The second issue that we find very often is issues with back-end data integration. What we mean by that is, how do you pull data from your existing systems, from your product life cycle management system, your PLM, or from your enterprise resource planning, or from your manufacturing execution system? There is always very distinct configurations and different systems across a supply chain, if you like. So it's always a source of concern and distress when you're trying to create a joint model with an organization or multiple organizations in a supply chain. And that links to the final point in there, which is a lack of any standardized information model. So there is standardized approaches, but those approaches don't get to the detail of, you know, how do I represent, I don't know, the nuts and bolts, for example, of a particular product. So there is a few big challenges there that are common across multiple use cases, multiple industries, and multiple applications. So to try to address that, we have worked on 6 or 7 grant-funded projects here over the past 5-6 years. And through those, we developed what we call a digital twin adoption pathway. So this is designed to try to standardize how we approach this digital twin creation from the most basic level in phase 1 around the individual business need and the value proposition for the business. And there is a set of tools that we use in there to try to document what is it that your business is trying to achieve and how that's going to contribute to a sustainable value proposition. We then move into use case definition, and that is specifics of what you want to use your digital twin for, and then what data sets you need to collect, and what are the sources for those data sets within your organization and your supply chain. Phase 3 is around setting up a model. So we have a bespoke 3D ontology that we use here. So that's just a way of showing, in 3 axes, what data sets you need, what phases of your life cycle you're looking at, and then what degree of fidelity that you are looking at for your particular implementation. Once we define those in the first 3 phases, then it's a question of application selection, infrastructure development, and then interactive piloting before you get into your final solution that you roll out. So we tested this model before, we used it multiple times. We believe it's very helpful. Nick will be describing a solution that has been through that loop and that model later, and hopefully will come to life as a way to try to address those challenges and help accelerate adoption of digital twins. So when we use this adoption pathway, very often we use it in combination with our innovation model. So we have a particular approach in Coventry University on how we engage with companies, and it's based on 4 simple steps, where we start with ideation, trying to identify what the needs of the company are and what their roadmap is. So normally we ask a few very basic questions. What is the challenge? What are the threats and opportunities for you? And then we try to align the outputs of that discussion with our ongoing resources, facilities and research in the university. And based on that discussion, we move on to step 2, which is identifying ways to pilot it in a very quick and fast and low cost way. So we de-risk those technologies to our partners. And normally what we look at in phase 2 is use cases, potential solutions and technologies, and then how we can build a viable business case. Once we go through those phases, and the typical innovation funnel works here, we start with 10 ideas and we end up with 2 that we get to stage 3, which is where we try to do a minimum viable product. And normally at that stage, we look for government funding, both UK and international level, European funding, whatever funding sources we can have to help our partners and collaborators de-risk their work in that particular field. So the main questions there is, how do I de-risk my investment? How do I develop the right capabilities? We do a lot of work in teaching and continuous professional development to make sure you have the right capabilities to adopt and roll out in your business. We also help you find the right resources and partners. And that leads to step 4, which is really, where Nick will take on from me, and he will describe how Hyperbat as a new business had a few challenges and how we work together to identify how we could use digital twins to address those challenges. So we'll hand over to Nick now, who will talk a little bit more about the Hyperbat use cases.
Brilliant. Yeah. Hi, everyone. So I'm just going to talk about quickly kind of who Hyperbat are, what we do, and kind of then I'll go on to, as Marcus has kind of mentioned, I'll go on to the digital pipeline and how we wanted to kind of innovate, but we had certain challenges along the way, and we saw how kind of digital twins and the metaverse can help us overcome those challenges. So yeah, Hyperbat is a joint venture between WAE and Unipart Manufacturing. And what we aim to do is make electric vehicle battery packs, specifically designed at kind of bespoke high performance models for kind of OEMs who haven't got the access to kind of their own facilities or somewhere kind of to a high level investments needed. We're trying to lower the barriers to entry to the EV world for kind of bespoke high end automotive. So yeah, next slide. So this was kind of the kickoff project for Hyperbat. It was through a government-funded project, the APC6. It was called H1Perbat. So a little variation on the Hyperbat name there, and it was for the Rapide E. So this was a refit of the Aston Martin Rapide. It was kind of a full powertrain change out. As you can see in the bottom left there, there's a picture of the actual battery pack, and it's taking place within the car of the drivetrain, the fuel tank and the engine. So it was a complete kind of refit to make the chassis and the body into an electric vehicle rather than design it from the ground up. They take an existing kind of architecture and modified it, which did lead to a lot of challenges. So kind of when you're designing a vehicle to be retrofitted to be for EV, it means you're quite limited on how your battery cells and battery modules are going to fit in the car, which they already need to fit into existing architecture, and that led to a lot of kind of complex designs, challenges with the design, and things that we had to almost compromise on. So and this is where we needed to look into digital solutions to help us control the manufacturer and ensure we were getting right product right first time. Thank you very much. And this is kind of more of an infographic to explain the level of that problem. Not only is the design, there was a few design challenges, but there was also an incredible amount of kind of traceability and product conformity challenges. And this is what this value stream map is showing about how complex the design was in terms of 14,000 components and across 300 unique part numbers. And then in terms of conformity and product testing, there was over 500,000 data sets collected per battery pack, which is quite staggering. You're not going to collect that on paper, unfortunately, as much as you want to try to. You've got to make sure that every single one of those data sets has been checked, it's validated, and it is actually correct to the conforming product. And then this is kind of our little digital pipeline that we did with Coventry University on how aspects of digital twins and the metaverse can help us at every stage of the product pipeline. So the digital twin of the product at the design level, the production planning, which is the digital twin of the process, which I'm going to kind of expand on in a second, virtual commissioning of machines, because a lot of our technology is bespoke and it's not easily accessible, sometimes not accessible in the UK. We've got quite a lot of suppliers for our machines in the EU and the US, which is it's a very time consuming to get out there, do in real life commissioning, especially if you find kind of problems and you have to come back to the UK, they've got to fix something, you've got to go out again. And then once we start moving into production, managing that 500,000 points of data is incredibly hard when you're trying to make 10, 20 packs a week. It just escalates incredibly fast, which is why we want to have a robust data strategy at that point. And then moving on from production, how can we manage and maintain our battery packs once they're out in the field, which is another challenge entirely. Thank you very much. So this is the use case at every stage, and we're going to talk about the number 4, which is the digital twin of execution there, and that's how we can make sure our process is conformed to, make sure we're building the same thing every time, make sure we've got traceability, that every product has been built to the way we intended to build it and with what parts. So next I'll talk through the video here. So this is what we've got. This is actually live from our shop floor. It's recorded from our shop floor. So I'll just talk over while Renata's doing her assembly station. So you can see this is a Lotus product in the top left. This is a sub-assembly for a battery pack. And each one of those, we call them modules. So there's kind of blue crates on the picture in the top left there. Those contain 32 cylindrical cells, which is essentially like a AA battery, but a bit beefier to drive your car around. And this is a very complex process. The build can take up to an hour, 2 hours. Imagine an hour, 2 hours of time. If you've built it wrong, it's an incredible cost to the business to strip it down, start again. And we can see, as Renata's building, we can see how the tools in the bottom right, we are using a webcam with some image processing software on it to ensure that she's using the correct parts at the correct time when the process asks for it, and that she's able to interact with the machine as she goes along, as she's kind of moving through the instructions. She uses her hand as kind of button. There's no button presses for her kind of on the physical screen. She's interacting with the fixture when she needs to. It's telling her where to fit products now. So it's telling her to torque the earth stud and apply Loctite as she's doing it. So we'll see as she goes to do this, it'll hopefully turn green. So as she turns it, the machine will also automatically move to the next instruction. It'll tell us to rotate the bench, which is the next step in the process, because we build on both sides of this cooling plate. So she's rotating the bench now, and then it'll go across and go to the next stage of the process. You can see kind of there's a live version on the screen of her what parts to pick, and then it'll tell her where on the cooling plate to fit them. So we could watch the rest of this video. I'll go to the next one and kind of show the realized benefits. If you want to go to the next video, sorry, the next thing like that. So that one will need muting. Background noise. So how this bench helps us is it's a conformance to process. So we can ensure that every time we build one of these sub-assemblies, it's built right and it's built to the process that we have. And we can, this isn't something limited to kind of digital, we can do that with fixturing, but for the complexity of the part that this is, we need the world's most complicated fixture, or we need to break it out into about 30 different sub-assemblies, which is kind of, it's possible, but it's not effective. It's not, it doesn't kind of make us different. It's something that we do usually. Whereas this digital approach, we've got one fixture, we've got one webcam, and then all your fixturing's done in the process software, which is what I'm doing now. So kind of on the video. So it's talk for too long. So you can see that this was kind of a problem we were having when I was setting up just for the video actually. And all it needs for me to do is to come up and interact with the keyboard, interact with the computer, and I can do that from anywhere. So it's kind of, if we had a problem with a traditional fixture, we'd have to send out the fixture to a fixture manufacturer, get a quote, pay them. It would take turnaround for them to actually kind of either machine material away, add a clamp, whatever. If I can do it in 20 minutes, I log onto the computer from anywhere in the world, it's got internet access, I can adjust settings, I can change kind of images that it's recognizing to, and that is all done kind of with limited effect to production. So that's kind of the challenges we've solved with it, and we're looking to expand this across from kind of ground up at every level of our business. We want to have this conformity to process and this ability to trace back our product from the parts we've got out from stores and put into the battery pack, all the way to the serial number of the final battery pack that we send to the OEM. We'll have detailed knowledge of every part that's gone through the process and pictures at every stage. Mm-hmm. And that's what this kind of digital and metaverse solution gives us.
Great. Well, thanks, Nick.
No problem.
So I guess, it's important to highlight that the whole strategy that Nick presented across the different stages there is enabling this, right? So the data that he's using to represent the modules, all the information, all the checks is all coming from the design environment and then moving into the production environment in a very seamless way through the digital world, where the engineers can interact with it and they can enable, physical solutions like this with, virtual fixturing using augmented reality. For those who perhaps never seen these systems before, so overhead there is projection and there is vision systems. So the instructions are being projected to the user on top of the surface, and then the vision system is validating everything that they are doing. So quite I guess a practical application of virtual and mixed reality that is based on this enabled industrial metaverse, if you like. So I think that's where we will leave the use case there. Just in terms of conclusions, I think I just wanted to emphasize that advances and use of digital twin and industrial metaverse is already here, and people are using it in different forms. Hyperbat has a very practical, manufacturing use case. We work with OEMs before in very much design intensive and product intensive uses of industrial metaverse and digital twins for developing and testing products. But the idea that this is coming in 10 years is probably wrong. It's coming now. And the sooner you get into that, the better. You can start reducing wastes. You can start automating even physical processes like the case in Hyperbat. And that frees up, it doesn't replace people in this case, but it frees up people time to look at different forms of efficiency and productivity, rather than if you think about traceability of products without that system, it's highly complicated, a lot of data collection and data amalgamation and processing before you can actually see what's going right or what's going wrong. So in this example, you see it in real time. So we think the early adopters of this will have an absolute, a business advantage, if you like, from a productivity point of view, but also from an interactivity point of view with their customers. So the ability to estimate cost of production, to estimate, how you're going to make a product and therefore where it can be made and what machines you would need is phenomenal. And I think people should really start working on it. So these are a kind of last slide, and is a call to action, right? So from our point of view, the moment to start developing skills and capabilities on digital twin is now. So if you set it up as a foundation for your business or for your products, you will have success and you get the rewards for years to come. But you need to be mindful that successful innovation in this field is very challenging. So we recommend using collaborative approaches to help you accelerate and de-risk it. So working with EBN universities, both UK and EU based, and partners like Uniport and Hyperbat that already implemented it, is very helpful to know what to do and what not so much to do. So if you are interested in collaborating with us in this area, please feel free to contact us, to contact our EBN colleagues and our Coventry University colleagues in Brussels, but also in Poland. If you are in the EU, we will be more than happy to engage and work with you on projects. I'll leave my contact details in there on the last slide, but you can reach us through, LinkedIn or the website, and you can find Nick on LinkedIn as well if you want to ask any specific questions. And I think that's where we will leave it. I will stop sharing and hand over back to the colleagues. I think Laura is probably going to pick it up from here.
It's me, Marcus, actually. You're coming back to me. So thank you, guys. That was brilliant. It was fantastic to see the deployment of digital twins in such a really clear case study, actually. And to bring it to life like that was fantastic. I don't want to delay too much because you've had quite a few questions and some good questions coming through. So if you guys are happy to take those, I'm just going to work through them now. The first was from Michael, who, when you were talking about the 3 metaverse paradigms, Marcus, he was asking about where the sustainability and environmental concerns fit into those paradigms.
It's a very good question. From, I guess, from an industrial metaverse point of view, sustainability is very much a mandatory requirement when we're building our digital twin models, right? So we have all the data to build a bottom-up model representing the physical thing, and as part of that data set, we can estimate, cost, as I mentioned, going back to raw materials, to processes that you might use, all the way to final cost to customer. But in parallel with that, you can apply carbon accounting and life cycle analysis practices as well. So we've been, again, with Hyperbat, we've been developing a tool set that builds upon existing cost modeling tools, but it creates a model that is focused on the carbon footprint, and it allows you to forecast what your likely footprint is, depending on your manufacturing materials and supply chain choices. So that high fidelity model is a critical enabler to say, this is the result of my choices from a cost, quality, and environmental sustainability point of view. And we have seen in more than one occasion, choosing to go with a more expensive process in the short term to achieve a long-term sustainability benefit. And we've seen that as a thing that was enabled, a decision that was enabled by that digital model. If it wasn't for the digital model, it would be very difficult to create a business case that finance within the organizations would accept as a viable business. Because you always, particularly in automotive, you always trying to maximize your very small margin that you have. So you try to limit your investment. So I think, in a simplified way, the industrial metaverse will enable us to have visibility of sustainability impact factors and then address some decision points across product design, across manufacturing, and across how the products are used to improve our sustainability metrics, if you like. I hope that answered kind of the question that Michael asked, and thanks for the question.
Thanks, Marcus. Slight change of tack here for Bogner's question. I think you touched upon this briefly, but Bogner's question was asking whether or not digital twins could be used for safety purposes. Yeah,
I'll let Nick answer that, because his use case was initially designed based on safety.
Yeah, so we do kind of, especially in the EV world, it can be quite hazardous with the voltages and the currents that are just around and kind of in the environment of an electric vehicle battery pack. You might have caught it on just on the start of that video. We do have a conformance in on that sub build on making sure that the operator use gloves. So when they start the operation, they have a check for the blue PPE on that people are wearing. But that we can take that a stage further, and it's kind of an application we're looking at for the entirety of our hazardous voltage room, is to have cameras are looking, especially when they're doing the arming process, which is where they take the battery pack from kind of a normal voltage up to vehicle level voltage, where we can make sure everyone's wearing PPE, and they're also where people are stood, because there's we isolate areas of the room based on which pack we're arming at any one time, because there's a safe distance for people without PPE to be wearing and to be present. So we use image recognition and almost PPE recognition at that stage to make sure everyone in the area is wearing the right PPE, and people who are not in the area are far enough away behind barriers and are not at risk. So yeah, a big use case there.
Yeah, just to mention, you know, that those batteries, when you get to the final field connections, they go up to 900 volts.
Yeah, there's 900 volts. There's a lot of power in it.
Yeah,
they're not nice things to be around.
So the technology in this case is being used to make sure when you're making that final connection is as safe as possible. And what you don't see in the video, but is implemented there, I've seen it firsthand, is if there is anything out of place, the system will isolate and shut down. So there is no risk of the person making a mistake that might lead to serious injury or death in the worst possible case. So yes, I think, this is just one use case, but there are multiple use cases around health and safety protection.
Perfect. What I'm going to do, guys, Marcus, Nick, are you okay to stay for 5 or 10 minutes after 4, just if we take some more questions? I'm conscious we're due to finish at 4.
Yeah.
What I'll do, one last question, then I'll hand over to Laura for some closing comments. For those people that need to leave at 4, you can do, but if you have questions for Marcus and Nick, please feel free to stay, and we'll stay on for a little while longer. Florian had a question, which is just a quick answer, I guess, guys. But how can, given the nature of what EBN are doing as a membership organisation, but how can business intermediaries such as the EU BICs support next generation companies to adopt metaverse and digital twins and understand its practices? And you talked about the early adoption on one of your last slides, Marcus. How does that work in practice? How do we get more people involved?
Yeah, I think, the EU, the BICs, and the EBN as well are a great place to go and look for best practice, right? So something that we do before we conduct any research in the universities, we look for, where's the state of the art, and can I get in touch with the expert in the field, and can I see how it works before I go and invest into it? So I think people should use EU BICs and EBN and the contacts that you are making today to build a small network, and that's how we develop our approaches to applications in this field, is by working with I mentioned the IDTA in Germany. We do work with large tier ones, we do work with OEMs, we do work with very small tech companies, and there is a network in there that understand each other and help each other. I think that's the best way to a successful adoption, if you like.
Great answer. Thanks, Marcus. Okay, Laura, I'm going to hand back to you. And as I say, if people would like to stay for another 5-10 minutes for the remainder of the questions, that's great. But Laura, over to you.
Thank you very much. And thank you very much, because actually this links pretty well as well with the open invitation that I wanted to do just for the closing on what to do as a business support organization to help the next generation of entrepreneurs that are willing to approach this type of technology. Well, best place we're going to discuss this and much more is actually at our annual EBN Tech Camp, as Paul mentioned at the beginning of the webinar. This is taking place at the Coventry University, fantastic campus and their simulation center. The next from the 18th to the 20th of October. To the EBN members that are around, there is a short, just to remind you that there is a very short survey just to get your inputs on what you would like to see happening those 2 days. And then thank you very much, Marcus and Nick. Really, we could not end in a better way this webinar series. We started, I think, back in February, talking about application of extended reality solution application to creative industries, and then we touched upon health, and then mobility and transportation. Today, advanced manufacturing, just to say how broadly actually this technology can be applied, and they are there. I mean, all the questions that also were in the chat regarding sustainability, environment, sensitiveness, safety, all of these things. I mean, it is important that, I mean, it's the right time to talk about them, learn how to best use and all the good potential that these technologies has. So a big thank you from the EBN Secretariat for such a great webinar and great collaboration with Coventry University colleagues. So for those of you who still have some time, please remain just to cover a few more questions for Marcus and Nick. Thank you very much for everybody else.
Thank you, Laura. Thank you. So just flipping back to the questions, Michael had another question about, I think one of them has been answered during the presentations, but a good one actually for you, Nick, was how was the fidelity of the project Hyperbat decided?
Very good.
It's a good question.
Do you want Michael to expand on that, Nick, or is that enough?
I can do, but I think I think I'm all right to answer it. I think there's a lot of kind of low-hanging fruit in terms of what we can digitize and what we can innovate on. There's kind of, you can go the whole hog, you can do life cycles, and you can do entire digital twins of kind of from cradle to grave. But it's important to look at where would you get most value and where would you kind of avoid the most cost. So if we were to not have implemented this digital solution to our process, where would we be? We'd be in a place where we're building product, but we've got 35, 50 fixtures controlling that one process. And we've invested a lot of time, we've invested a lot of engineering support and a lot of material in terms of bringing that kind of process online. With where we identified kind of the easiest area to kind of the biggest wins. So the biggest wins were in process, where we can, the technology already exists, we have the experience with the technology, and we were able to implement to get realize those benefits much quicker. And now we're looking at more of the higher level stuff of kind of that's harder and longer term to implement across an entire business rather than just one process. Does that make sense?
Yeah, I can add something to that answer as well, which is, the guys have started with the functional requirements, right? As you do with developing the production facility for anything. So they had a product that had a set of functional requirements that they knew they need to monitor, and they knew the frequency in which they need to monitor and test it. And that almost gave them a control plan that they then look at the functions that a digital twin or an industrial metaverse environment could produce, and then they work back the requirements for fidelity from there. So, testing of cells, for example, they know they need to test every single cell for voltage and continuity. And that sets the parameters that they need to track and how do they design it. So the thing that is not shown in that video is that massive amount of work that these guys did, linking their design requirements to their manufacturing requirements, to then their control plans and monitoring strategy. And that creates the feedback loop. So you know now when you're designing the next product, what the actual production output is likely to be given the constraints that you have and the processes that you're using. So you can optimize the design for the next life based on that. So it's a iterative process. As you design the next life, you might want to go higher fidelity in an area because you had problems there and you don't understand why. So battery welding, for example, you know, in a battery with 6,000 cells, you might have 12,000 laser welds that need to be right first time every time. So fidelity on that one, you know, you're welding at 600 millimeters per second, which is pretty fast. So frequency has to be very high. You know, so there is a variation of fidelity and frequency of monitoring there that will be dictated almost always by your functional requirement of the product and process. Hopefully that makes sense.
Absolutely, absolutely. And I think so. Vasilis's question builds on that, Marcus. This is something that I know that you're particularly interested in. And I think again you touched upon it during the presentation, but do you envisage that the digital twin models should also consider the human operators or the monitoring of the human operators to include them in the manufacturing metaverse? I know you're doing that already, but can you unpack that a little bit?
Yeah, absolutely. I think we see that as critical. And again, you know, in the spirit of good innovation and collaboration, we are working with other disciplines beyond manufacturing. We had an actual workshop last Friday with our colleagues in a research center for dance and in a research center for psychology and in another research center focused on human factors. And as strange as it might seem, in dance, we have very well developed systems that we can use to represent body movement and to interpret body movement, to know if someone is, for example, bored, or if someone is tired, or if someone is not well physically. And then you can tailor the reaction that you do in a much more active manner. So you don't wait for someone to, you know, in the case of Nick, someone might be electrocuted there, right? And because this is DC voltage, it seizes all of your muscles. You won't be able to scream or do anything. But using vision systems and models of the human body, we might be able to tell someone had an electric shock here, and we need to isolate the station as quickly as possible to avoid damage. Right. So yeah, human modeling is very important for us from a health and safety, but also from a productivity point of view. Inclusivity is another big aspect for us. So based on your profile, we might know your height, we might know your language preferences, we might know your level of skill, and we can tailor the instructions being projected at the work assembly to suit your particular needs. So you can be as efficient as you possibly can, given your particular condition. So we think that's a much more inclusive way than having standardized instructions to everybody, no matter if you are tall or short, you know, fast or slow. So we see a potential there to improve inclusivity and health and safety massively by creating these human models. Obviously, that needs to be contrasted with the risks around privacy. So we are very careful to make sure we don't use these digital human models for decision making around, you know, management of individuals based on production outputs. We need to be very careful with all those things. We desensitize the information, so we anonymize it, and we make sure we are very careful with GDPR in this context. And there is a whole research area around ethics, particularly related to autonomous decision making in this sort of context. So yeah, we do have we call it a cross-disciplinary research group, which is, you know, academics from multiple disciplines, but also includes society and industry into those groups. And it's something that we very much take seriously. So if there is anyone interested in human modeling and data from humans, we are keen to work with you as well.
And I'm sure that's a really key part of adoption as well, Marcus, that whole human modeling approach.
Yeah.
Great. Okay, so I've got one more question and then we'll close the session. And I'm not sure if we can answer it actually, but I'll ask you anyway. So Elif has asked about the total cost of implementing the new system to the current facility. Now, clearly there are going to be some commercial sensitivities there, Nick, but I wondered if could we phrase it in a way that is there anything you've done around cost saving for the introduction of the digital twin that might be able to talk about?
Absolutely, yeah. So we use a proprietary software system. So there's a lot of different kind of manufacturers and developers of systems like that, and those would have different costs attached. But in terms of hardware and kind of what we use, it's very, very kind of open. Kind of you can integrate anything into the software. So we use a webcam, a depth camera, a projector, and then a PC. So that whole setup is less than £5,000. And then in terms of the cost saving, it's £5,000. The software is kind of, there's whoever you go to will give you a different price for that software. There's things you can do on price and the software and the training. And then in terms of kind of non-digital solution, we'd have fixtures, the 30 fixtures I've talked about in terms of for every step in that process of building a sub-assembly would be ranging from thousands to a few £1,000s. So you can see how there's a direct impact there from buying 30 odd fixtures to do the one process, just to having the very standard bits of kit like a webcam and a computer where you can just do all your programming on there. There's a time investment, of course, but there's going to be a time investment with setting up fixtures, the lead time to get the manufacturers, things like that. But there is a direct cost saving on hardware, and then especially in terms of change. So the way the digital fixturing is kind of a key benefit is if there is then a product change going forward, say our customer wanted to change something on the design, we'd have to refixture that. We'd have to again go through the entire loop of rebuilding a fixture, getting it sent out, working on quotes, trying to improve the price. Whereas once we've got the system implemented and we can just use a webcam, or we can use depth camera and then the projector, all it does is it takes up 20 minutes, half an hour of the programmer's time to set up the change into and implement it into the program.
Yeah, I think that flexibility there, Bo, is really important. So normally when you do a program like this, you buy all the tooling and all the fixtures and you only use for one customer, right? And one program, and then you throw it away. And then you need to buy it all again. In this case, these guys used it for 5, 6 different customers already. And they will continue to use it, until there is a better version that they will go and procure. So it's very flexible, and it's the benefit of being digital, right? So it's
But that alone is a clear case for investment in the technology, isn't it?
That's right. But if you never deployed it, it's quite difficult, right? To go in and say, depending on your operation, it might be, I don't know, an outlay of £100,000 if you set in multiple stations, right? Depending on the precision that you need, and getting that signed off, as surprising as it might be, is harder to get £500,000 of tooling signed off. And the reason for that is finance is used to signing tooling off, and the customers are used to paying for tooling. So there is a whole, I guess, soft side of introducing this to customers and internal and external customers in that case, so they understand the technology, the benefits and the impact. So building that business case and the use case is really helpful in terms of getting people to understand the cost benefits, but also the long term. I can guarantee to you, every time a customer comes to see these guys, they will show that as a unique selling point for the business. How if you change your design 6 months into production, I'm not going to ask you to pay for another set of tooling. I'll just go and reprogram it. And if you need a full traceability report, you can have it for every battery pack. And that plays a role into, some of you guys that might be involved in battery manufacturing, you probably heard of the battery passport and the new directive at the EU level, right? So this system is fully compliant with the data sets that you need to collate to build a battery passport, and actually goes beyond and provide further evidence. So I like to think that this is as future-proof as you can get, and as cost-effective as you can get from a manufacturing point of view. Obviously, not suitable for every single operation, Paul. If you have a very high volume manufacturing facility building, hundreds of thousands of battery packs a year, probably the easiest thing for you will be automation, fully automation. But for anyone doing, mid to low level production with very high level turnaround of design and design change, then this is a very well worth solution to explore.
I think that's a perfect point to end. So I really thank you guys for your comprehensive responses and for the presentation. Great stuff. So I'm going to close there. Laura, any final words from yourself?
No, not really. But again, a big thank you also for the detail on how you handled the question. I think I was really, really useful.
So thanks all to the audience and for those that have joined us online. I appreciate your active involvement and questions, and enjoy the rest of your week. Thanks again.
Indeed. Thank you. Bye-bye.
Thank you.
Thank you.